next speaker is Michael Flaxman, who many of you may know. He's received his PhD from Harvard, has been a professor at MIT, co-founded GeoAdaptive, has his new second startup, Geodesign Technologies, worked here at Esri as an industry manager. A lot of his work has been in the development of spatial scenario planning tools that enable us to do spatial analysis with rigor and with creativity, and we'll be talking this morning about integrating scenario planning and geodesign. Mike.
Thank you. It's a pleasure to be here in an audience. It's a nice balance for me. I know half of you, and I'm getting to know the other half of you. So we're still growing, which is good. My latest little venture is a San Francisco-based startup focusing on geodesign. So I'm putting my money where my mouth is. To date, we're concentrating on consulting and some custom technology development. Some of our kind of current sponsors and clients are the National Science Foundation's Water Sustainability and Climate Program, the Florida Department of Environmental Protection, which is sponsoring the Beaches Habitat Conservation Plan, which I'll mention later. A couple projects with USGS, supporting landscape conservation cooperatives and doing some dynamic refuge, in this case nature refuge planning, and a project we just finished for NOAA on marine climate adaptation planning. But today I kind of want to talk about one very, very little project, actually the smallest thing I've done all year, but to me it's almost the counterexample to a lot of the beautiful work we've seen today. I wanted to show you something fairly ugly, came across my desk. I was asked to help, and I'm in the process of helping. Basically, theme of big development comes to small town. And it's something I want to do better next year, and I want to be prepared to do better next year. So in the kind of spirit of Doug Walker's talk or Carl's, I'm going to show you something quick and dirty that I think we're actually well positioned to do better next year. At least I hope so. So obviously for a small firm, implementing the lofty ambitions of some of our geodesign definitions is challenging because we have to do this in a professional practice context where, as Doug just mentioned, the tools keep turning over and the clients aren't paying us for R&D, they're paying us to get something done, usually in short order. So I think both Doug and I, and a lot of us on the landscape side, sneak in R&D. But to give credit where it's due, a few of the key ideas that motivate our work. I won't summarize Carl's hour-and-a-half talk, but a couple of things for today that really were important across the board in what we do are the importance of having an overarching intellectual and technical framework that can support and evaluate many options. And Doug just showed examples of that, so did Kunjan. Scenario planning and impact assessment, tightly wedded. And recognizing multiple design methods and their interactions with scale and problem context, another kind of common theme here. But a couple people that aren't here that I think have influenced a lot of the work we've seen today as well. Ian McHarg continues to influence me. And also Richard Foreman's work on irreplaceable spatial patterns, especially patch size and landscape connectivity metrics. And I think that those form the ecological backbone of a lot of what we do still. Some other thinkers that we're spending a lot more time on are the kind of early champions of ecosystem services. And so there I'm crediting two out of many, but Bob Constanza for a seminal science paper taking on the green infrastructure of the planet, and Gary Moll, who I work with fairly closely, and used to be at American Forests. Some of the work that I'm doing today was with him and his current NGO. Basically, even 30 years ago, he had the concept that ecosystem services can be quantified in GIS, and they can be developed in formats that support local decisions. And he went out and worked with hundreds of towns across the country from a forest ecosystem services perspective. However, part of the challenge in doing this is the kind of missing manual problem. Where are the missing technical methods? And had a little fun with my names here, but I'm looking for some automatic McCargianism, or Professor Yu's defensive strategies. Basically, we need to be able to get resource inventory and spatial defense strategies kind of into the core of what we're doing you can negotiate how big the stream buffer is. You can't negotiate ignoring hydrology. And so we really need to kind of up our game in what we start with, and hopefully we can build those rule sets into the next city engine. Computerized Steinitzyism, basically we need, McCarg was half right, but we really do need to pay attention to real estate attractiveness and competition as it occurs on the landscape for change, and if to ignore that is really foolish. So we need computerized methods for doing growth allocation. What I'm calling Mall on Demand for Gary Mall is basically we need to be able to quantify ecosystem services on the fly, and that needs to be on tap. It needs to be easy. Of course, making all this easy is devilishly difficult. Overall, we're really trying to develop digital scenario planning that really has characteristics that are uniform across the use of a lot of geodesign, a lot of scales. We've got to manage many plans or scenarios, many evaluations, and many participants. And I'll have some ideas about that. So the other motivation for my topic today is that the current generation of geodesign tools that are coming online are largely sketch-based. And so I really been asking myself not, what do we do 10 years from now, but what we can do this year that's going to move the needle forward. So what simple things can we do immediately with the available tools and coming online tools? That said, a lot of my work is designed by rule. Large projects need performance-based assessments and methods that work at large scale. I won't talk about that so much today. Talked about it a little at last UC and will for the next one. But the ultimate goal is really to keep things interoperable. I think you've seen a number of examples from professional practice. The great thing about professional practice is we are pragmatist. We will use the best model anybody gives us that works. And basically, we need to find ways of keeping those things tightly coupled so that we can get interaction and rapid iteration. That's fundamental to our method. That's fundamental to being successful at this. So that's the only non-negotiable part. We can't do an NSF research project for every design we need to do. So leveraging geosketching gives us the ability to rapidly generate alternatives, and I want to make the second point always to do fast evaluations. And really what's coming on stream this year is a subset of all the evaluations you could think to do, but it's an important subset. It's really overlay with pre-computed resource vulnerability layers. And that's kind of what Bill's team showed earlier. And that doesn't solve every problem, but it solves a lot of them. So let's use it. I'll show some examples. One of the challenges is that with the current state of the technology, it's really important to stage appropriate constraints and evaluations. Otherwise, sketch planning can kind of really lack the information to cite things appropriately. And I'm going to show you, again, a kind of devil's counterexample. In sequential design in particular, that leads to kind of irreversible design errors, like misplacing dense centers because you ignored where the hydrology is. And current geodesign pens or tools don't really give you direct feedback about the environment. That's kind of always been a long-term vision to be able to have a tool that understands terrain and can follow a contour or can do a takeoff off of a stream and interactively generate a stream buffer. We're not there yet. So we need an immediate proxy. Unfortunately, we have one from the tradition of overlay masking and constraint-based work. So I'm going to show you an example from a very small town in North Carolina. Happens to be 6,000 people, and you can kind of see the scale of it. Located on the western edge of Research Triangle Park, however. And my involvement in this is relatively recent. I was asked by a conservation NGO to evaluate some of the recent development proposals that have been made there. This is how they see themselves. It's largely still a rural place, traditional small town. However, apologies, the legend got lost here somewhere. Traditional mid-century zoning for the US, so it's got a highway bypass, it's got a central business district, and basically is zoned with conventional single-family residential, progressively lower density from the center of town. The winds of change are strong because a developer about a year ago came to town proposing a large-scale and really fairly dense development. Again, a town of 6,000 people, somebody shows up, they want to put in 27,970 new housing units. on 7,000 acres. This is a town that the planner is part-time. The public relations department of the developer probably has more employees than the sheriff's office, right? So they're proposing a huge thing, 22 million square feet of R&D space, Research Triangle Park 2, right? And the rhetoric behind the plan is new urbanist down the road, with these two artifacts being really almost the sum total of what the public has to judge this plan on at this point. There's supporting fairly vague documentation, but this plan, I had to get an intern to redigitize the plan because the developer wouldn't give it to us in digital form, and the town didn't have it in digital form. And then there's one rendering of something. So not surprisingly, this is a controversial plan. Pittsburgh is not for sale. Every resident showed up at one of these meetings. And they're basically requesting the town to rezone this entire area as a single planned unit development. And they're asking to nullify existing watershed protection zoning overlay that comes from the state, which actually quite sensibly has impervious cover-based empirical measures. So the blurry plan, I apologize for it, but that's actually kind of the state of the data as we got it, to be fair, right? You can barely even read the legend, and yeah, that's what the public got. Classic, big development comes to small towns. So the proponents say Chatham Park will be the best expression of smart growth values, incorporating long-range regional considerations of sustainability, open space preservation, targeted goals to reduce natural resource consumption, connected technology. Wow, okay. And, the opponents basically say, at this point, developers have requested approval of a master plan that would be a blank check, and said, trust us. So, the opposition is nuanced. People do want growth there, but they actually do want sustainable growth. And the developer, if you take them at their word, they want this, or they say they want it, but the planning methods really really are hard to evaluate and makes it very, very difficult to evaluate. So what we did in about a day's work really is a classic McCargian overlay. So we obtained the relevant environmental geodata for the area. The green map underlaying this is not my work. It is the work of the county of Chatham County, and it's an environmental sensitivity index in a 9-graded scheme. And all we needed to do is literally to kind of overlay that data and figure out the intersects. And the relevant point is the state, county, and local groups had already created environmental inventories. They'd even created them in a simplified format, should be usable by anyone, and it got ignored. So this is where I don't want to be next year, right? The other thing that was obvious immediately after overlaying this, and in context, but not in the plan, is that the site happens to be located to the largest regional reservoir, which is currently impaired, and it's the regional drinking water supply. So funny they didn't mention that in the proposal. So I felt the need, probably a hazard of hiring me as I always do scenarios. So I didn't have an alternative plan, so I decided to make one in a day. And to do it in a brutal but reasonable way, which is to make a shadow plan that just said, what if we take the developer's plan and clip away from it the environmentally sensitive resources as previously identified by others? In other words, what if we tell them to go back to the drawing board and start with McCarg, like they should have? And so I made a little model builder tool that I affectionately called IAN for Integrated Assessment Neural Networks Tool, just because it's a nice acronym. And it just takes in the known constraints that we didn't generate, other people in the local place actually had already generated, has a single parameter, how strict do you want to be, how many of these constraints do you want? And this is the original plan, and this is what's left of it after you do that simple exercise of masking. Now you can be less tolerant, more tolerant, but I think you can probably already see that a lot of the basis of the plan falls apart immediately. because they didn't even bother to put the activity centers in areas that are sensible. And I did a site analysis on park score, by the way, and about 10% of this area is within walking distance of the 750 acres of their 7,000, sorry, the 250 acres of their 7,000 that they allocated to public park. So, you know, simple model, simple results. 2/3 of the proposed area is contested. I don't want to say, because this is a quick analysis, that that's not suitable for development. It's got areas that need more careful attention. And basically, that's driven by both water quality and biodiversity. But even with this silly clipping method of generating a counterplan, you can still get a reasonable amount of development. We haven't done pro formas, but you know, likely you could make an economically viable project still in this region, should you choose. But more to the point of this morning's conversation, what we did is we ran Gary Mull's ecosystem services analysis package on this, City Green. And I'm not showing you the whole report, which is 3 or 4 pages, but just the water quality and quantity piece running off for just one of the sub-areas of the plan. And with this kind of rapid evaluation tool, you can get a sense and convey to the public and local decision makers that, you know, there might really be a reason to look at green infrastructure in this location. And lots of different ways to communicate this information, but for people that like dollars and bottom lines, $5 million just for fixing one component of this plan in current green infrastructure for stormwater that you're wasting. I don't even want to start on the water quality chart and what's going into that reservoir. That we haven't really quantified, but well, the impacts of it we haven't quantified, but clearly you don't want more of that stuff in your water. Second thing we did was to reverse engineer that report. So some people like the PDF version of the report. I'm a spatial planner, so I like to see where the plan is working badly and where it's working well. So here's the cost for stormwater infrastructure basically at the unit level. And so it ranges from about $100,000 an acre in red to less than $5,000 an acre in blue. And I would just submit that there's a really considerable difference in and across the site, which shouldn't surprise you based on what I told you already. However, now it's quantified inside a day in a format that hopefully will get the developer's attention, because it's not just the public that's going to be paying the cost of this, it will be the direct developer. So, you know, in summary, it's a quick case study. Apparently, as far as I can judge from the concept plan, they're ignoring some pretty fundamental environmental issues. I hardly got into the cultural. And the result, the bottom line is you can get a significant cost savings to the town and the developer by retaining and using the existing green infrastructure, not to mention hiring Kunjin and doing some regenerative design. So, you know, roughly the diagnostic, well, 3 misses, right? The professional practice firm that did this, the developer that did this is one of the people that did Woodlands, Texas, and hired McHarg. What did they unlearn in 30 years? I don't know. This plan has nothing to do with the Woodlands, Texas case, even though the hydrology aspect is important. So they need to go back to their library and implement the basic environmental planning defaults that any professional practice firm should put into their base product. They really need to deliver a clearer proposal to the community. To ask a community of 7,000 people to judge this scale of development based on a concept plan is really very serious breach of public responsibility. And I think they should find design value in preserving and using the existing green infrastructure. They've said rhetorically they want to, so I'll take them at their word. Let's hope they do. For the government, it's hard to be too critical. I mean, it's a very small town, right? This is a classic development problem. But they could at least require clear plan submissions and should have a trigger for super large projects to at least require basic documentation. Again, all of the map data needed to do this overlay analysis was publicly available. And then back to us, as a community, we need to have geodesign tools that really can deal with this very common development practice scenario. This is real world. It's not pretty, but this happens every day, and it really does influence our environment. So nothing in this analysis required complex analysis, with the possible exception of Gary's tool, which is actually soon to be web services. But the organization and architecture is important, and I kind of want to shift to that. Basically, we absolutely need supporting resource layers, and we all know that those are available visually as map underlays. We've seen that already. We need to get those, kind of into the analytic base, and that's one of my main things for this year. Constraint masking, even though it's manual for now, needs to be kind of into the geodesign tools. And more conceptual point, but sometimes counter-planning is necessary to provide a less bad alternative if somebody shows up with a real turkey. I presented in more detail this kind of concept at the UC last summer, but for this audience, I thought it would bear repeating. If you take Carl's framework and you flip it around, instead of thinking about process, you think about products, that actually is useful for technical folks to come up with endpoints that are then discrete objects, and for interoperability to figure out who's making which object or document in a form that somebody else can use down the chain. So in every project that we do, we use at least 3 types of representation and evaluations, and they are fairly uniquely different, and I've seen them in pretty much everybody else's presentation. We do constraint mapping, we look at resource layers, and we do attractiveness, and Doug just showed more elegantly an example of that. Well, if we're all using that stuff, it should have a higher level object in geodesign that we can then share what we do in these. On the scenario side, in terms of change modeling, basically we need to think about exogenous drivers like climate change and broader scale hydrology, as well as the details inside the site area, both in planning zone changes and physical changes. So I was happy to see zoning in the new city model, for instance. I think that could get us a long way. And then in impacts and decision, we obviously need a set of impact assessment tools. We've seen a fair variety of those. I'm going to show you a technical challenge on those in a second. And we need impact minimizing scenarios and optimized and mitigated scenarios. And again, Doug's example is illustrative. I mean, optimization tools, I think, on big problems are becoming quite important. So here's one of the remaining challenges that I really see, that basically we need to think about interoperable geodesign tools, and it's not too early to do so. So socially, GIS has always worked well because the independent ologists can create maps and designers and planners can overlay them and use them. However, many web GIS sites and models and potentially future apps largely lack that important interoperability characteristic. And so you have a lot of stuff that you find out there which is good as an app and a single web page, and yet it's not open to putting new data in the inside, and it's not open on the outside to getting a computable result. And so in the long term, if we're going to be able to mix, match, and chain models, something I learned working for Carl a long time ago, you can't have this kind of double dead-end system. You have to have chainable geodesign services so that you can end up with professional network diagram kind of like below. And that basically isn't so hard these days. Again, if you take this concept of flipping process and product, say what products do we deliver as intermediates? We need constraint layers. Well, they can have a URL. That's in techno slang called a REST endpoint. And they need a little bit of metadata to know how to interpret that you want to stay out of the wetlands instead of building on them, but not a horrific amount. And on the back end, we need to deliver results not just as graphical web mapping services, for instance, that aren't interoperable analytically. I don't want a map that's just a picture. I want the data of the map in order to chain it, to keep out of the wetlands, for instance. So the only technical requirement is really, put that into, again, a REST endpoint, a URL that you publish on a web service, and there's many examples here. But conceptually, it's kind of opening up both ends. And I realize why this doesn't get done, because it's harder, but it's not that much harder, and it will make our work go a lot further. So in conclusion, I think we've seen a number of individual and small group efforts currently underway that are really driving geodesign forward. And to me, that's great. We get a huge diversity of inputs and problem contexts and applications. And I'm thinking about how to use geodesign to help slum dwellers in Caracas. That's helpful. On the other hand, the not so great part is we're all small, poorly funded community. We are a small, poorly funded community relative to the size of the problems we're dealing with. And we need to get much more efficient to make an impact. And so part of this is, I think, interoperability. And so my challenge to myself and to you for this coming year is, how can I connect to at least one project presented here? So I'll give you my example. I'm going to go talk to Bree down the road, because I don't really want to make a new park score indicator. I would love the Trust for Public Lands to be doing that, right? And how can I get twice as many people to use what we've already done? And I thank Jack and Esri for continuing to bring new people into this venue and make an outreach effort for that. So I think we're well on the way. Thank you very much.